Hello and welcome to today's class. We are going to look at logarithm of numbers with the base of 10. We already know what logarithm is, and so I'm not going to try and explain what that actually means. However, I'm going to introduce us to a term. We call it logarithm table. All right, logarithm table. So some of us we know it, or log table, as some of us knows it. So some of us we know it, some of us we don't. But basically, we have a table of logarithms, all right? And usually, this table has its base to the number 10, all right? So all the numbers in this logarithm table are written in the base of 10. And basically, this table is supposed and was supposed to help students multiply numbers faster before the invention of calculators. And so, it's a subject that has remained in the curriculum and still important to know to this very date. So we are going to handle some very few basic examples of logarithm of numbers to the base of 10, so that you know how to read logarithm of numbers from the logarithm tables. All right, so we're going to start with our first example, and basically we are going to try and find the logarithm of the number 2.56, and we are going to do this from the logarithm table. So I want you to go to your logarithm table, and I want you to notice that we are having a table there with numbers arranged vertically and horizontally. All right. So in the vertical pieces, we are having the first column, and that first column there is the x column. All right. We have numbers there written from 10 to 99. All right. So one thing I want you to note is that the numbers in the x column, that is in the first column, are all in one decimal point. All right. So basically, the first number, that is 10, should be 1.0. The second number, which is 11, should be 1.1, though it is not indicated like that in the tables. And the last number, which is 99, should basically be 9.9. So all the numbers in the x column are actually written in decimal, are actually supposed to be in decimal notation, but not written in that particular case. So anyways, for us to read this number, that is 2.56, from the logarithm table, the first thing we want to do, we want to write it in its standard form. Okay, we already did standard form, so I am already guessing that this is not a problem to us. All right, so to write the number 2.56 in standard form, remember standard form should take the format a times 10 raised to the power n, and we're saying that a should be number between 1 and 10, where 10 is not included. All right, so 2.56 is already within the range of a. All right, and so we are just basically going to have it as 2.56, and being that we've not moved either to the right or to the left, we are going to have our nth value raised to 0, okay, because we've not moved the decimal point either to the left or to the right. It has remained as it was. And remember that anytime a number is raised to 0 is the same as 1. So this is 1. It's 2.56 times 1. 10 is raised to 0. That is 1. So we are then going to be in order for us to go ahead and write the logarithm of this number, of course, read it from the logarithm table, we are going to take whatever we have as the power of 10 here. Whatever we have as the power of 10 is going to form what we call the characteristic. So the number that comes before the decimal point. Okay, so we notice that in this particular case we are having 0, and so we're going to have the decimal point after that number, that is the number that we've raised 10 to, and then whatever comes after the decimal point we will get from the logarithm table. That is, we will go to the logarithm table and we will find from the x column the first two numbers, that is 2.5. We find 2.5, and then for the value 6 we'll find it in the middle section of that table. Of course, the logarithm table has all that's written out from 0 to 9. All right, so for the third, we can find it from the middle section of the logarithm table, which is going to be easy to notice. So go to your logarithm table in the x column and find 2.25 basically, which is basically the same as 2.5. So in the logarithm table in the x column, it is 25, but that is, as I said, all the numbers in the x column are written to one decimal point. So that's going to be 2.5. And then in the middle section, we are going to locate 6. And so that number that we are having in the column of 6 is what we will write after the decimal point. So we're going to go to 25, move to the right until we get to the 6th column, all right, in the midsection. So that number is going to be 4082. And I hope that you are able to see it. It's 4082. And so that there is going to be our logarithm. So the logarithm of 2.56 therefore becomes 0.4086. All right, so that is the answer for that. So for those of you that don't understand what this means, what this means basically is, we've done this. What this basically means is if we were to raise 10 to 0.4082, then we will get 2.56. That is what this actually means. That if we were to raise 10, because remember, we are saying that in that logarithm table, all the numbers are in the base of 10. So if it means that if you were to raise 10 to 0.4082, then we would get 2.56. So that is what that basically means. All right, so let us do another example, all right, so that we are able to understand what's actually going on. So we are having the number 3.752, and we are supposed to find its logarithm from the table, okay, from the log table. First of all, you want to write it in its standard form, and that's going to give us, of course, a times 10 raised to n. That's going to give us, because the number is already between 1 and 10, where 10 is not included, we are going to have it as 3.752 without changing the value of the number by moving the decimal point, times, and since because we did not move the decimal point neither to the left or right, we're going to have 10 raised to 0. Remember, any number raised to 0 is always the same as 1. And so the reason why this is important that we write it in standard form is so that we get the number before the decimal point, which apparently I've said we call the characteristic. In this particular case, is going to be 0, as 10 is raised to 0. So whatever number 10 is raised to always forms our characteristic. So that is the number that comes before the decimal point. Then the number that comes after the decimal point, which we usually call mantissa, comes from the logarithm table. So basically, we are going to go to the logarithm table, and we are going to attempt to find the logarithm of 3.572 from the table. And to do that, we go to the x column and we find the first digit, that is 37. Okay, remember, it's the same. All the numbers in the x column are written in one decimal point, though it's not been indicated. So we're going to find 37. Wherever we have 37, that's where we're going to stick to. And then we're going to move to the midsection and find 5. So it's going to be 37, and we move the midsection where we find 5. And note, you are going to get 5740. 5740. And so for our last digit, which is 2, all right, which is 2, we are going to move to the final section, the add section, the column where we are having add section. And so we are going to find where 2 is, and whatever number we find in the column of 2, we will add to what we already have, that is 5740. So when we move to the right to 2, we find that we are supposed to add 2 to 5740. So it's going to be 0.5742, 0.5742. All right, so maybe a disclaimer, something that I should tell you before I continue to explain the rest of whatever we are having. Of course, this is the answer. Before you find any number from the logarithm table, you always have to make sure that it is written in 4 significant figures. All right, you just have to make sure that it's written in 4 significant figures. Then it becomes easier for you to then go ahead and solve for the logarithm of that particular problem, as most of these logarithm tables are written in 4 significant figures. All right, so this here is the logarithm of 3.752, that is 0. So that basically means that because it's in the base of 10, it is 10 when raised to 0.5742 will give us 3.752. So what I am having here is what we call the index notation. So this is the index notation of this particular problem right here. All right, so that is it for these 2 examples. Let me do 2 final examples, a little bit complicated, then we call it a day. Awesome. So we are having the number 28.5 and we want to find its logarithm from the log table. So the first thing we want to do, we want to write it in standard form, and the standard form basically should take the form a times 10 raised to the power of n, and that a is supposed to be between 1.00 to 9.99 recurring, basically 10 not included. And so we look at 28, and 28 is way beyond that range. It's not between 1 and 9 or 1 and 10. So it's beyond that. So what we're going to do, we're going to attempt to move this decimal point so that we achieve the value for a. And so we're going to move the decimal point to the right. So that's going to give us 2.85 times. How many times did we move the decimal point? 1 times, to our direction to the left. And so we're going to have to raise our 10 to 1. Okay, we're going to have to raise our 10 to 1. So when you multiply 2.85 by 10, you still are going to get 28.5 basically. So the number of times we've moved the decimal point is what forms the power of 10 in that particular case. So we are going to then go ahead and read to the logarithm of 2.85 directly from the table. And of course, that means therefore that we're going to find 28, okay? The first 2 significant numbers there. We're going to start with 28. From the x column. So we come there and we find 28 in the x column. Then to find the value of 2.85, we go to the midsection where we have 5. All right, right here up in the okay, right up there. So that's going to be 28.5, which gives us 1.4548. So basically, the power of n here forms our characteristic, and then whatever comes as our mantissa we get from the table, and that is going to be 4.548. And so that there is the logarithm of 28.5, of course, to the base of 10. That means that if you were to raise 10 to 1.4548, you'd get 28.5. You can try that in your calculator and see what you are getting. So for our final example, final and last example, we are going to handle a very simple number again. That is going to be 379. 379. Say you are given 379 and you are supposed to find its logarithm from the table. How do you go ahead and handle this? All right, so we write it in standard form, and that's basically going to be a times 10 raised to the power n. Okay, so we want to make sure that 3.79 is between 1 and 10. Of course, 10 not included. All right, so basically that means that we have the decimal point after 9. So we move it to the left until we are having 3.79. All right, so then of course times 10. The number of times we moved that decimal point was 2 times, from 9 okay up to 7. So we are going to raise 10 to the power of 2 right there. And so for us to find the logarithm of this number 379, we are going to find, of course, the logarithm of 3.794 directly from the table. And so that basically means that in the x column we're going to look for 37, and then in the mid column we're going to look for 9. All right, so it's going to be 3.79. So when you read that, you're going to get that it is going to give you mantissa value 5786. So basically our all logarithm is going to be 2.5786. Of course, this coming from the logarithm log table, and 2 coming from the power of 10 right here. All right, so this basically means that if we were to raise 10 to 2.5786, we'll get 379. So that is it for this particular class. If you have any questions, drop it in the comment section. So for the next video, maybe we will handle logarithms of numbers less than 1. Logarithm of numbers less than 1. So before then, see you in the next class and have a lovely day.